Hi everyone, in this video we'll be learning how to find the reduced echelon form of each matrix here. So let's start off with this. So in our previous video we learned how to use Jordan-Gaussian reduction to find the reduced echelon form. So in this video we'll be having more practices on how to do so. So let's start off with the first example. 2 1 1 3. So first, before we make it to reduced echelon form, we make it to a echelon form first. So you'll notice that both rows have the x variable. So this is row 1, this is row 2. So you want to eliminate the x variable in the second row. So you notice that row 2 has a higher coefficient of x than row 2. Hence, we swap row 1 with row 2. We will get this 1 3 2 1. And now we can eliminate the x variable on the second row. So hence we add 2 times of minus 2 times of row 1 to row 2. Hence, let's start off 1 3. So minus 2 times 1 will give me minus 2. Minus 2 plus 2 will give me 0. And minus 2 times 3 will give me minus 6. Minus 6 plus 1 will give me minus 5. So now this is row 1 and this is row 2. So now we can make each leading entry into 1 because it's already in echelon form. Therefore, the second row we can divide by 5, divide by minus 5 so that this will be 1 because this is just the matrix. Usually in equation we have the constants here which they're making it to be the argumented matrix. So hence we get 1 3 0 1. This is row 1, row 2. So now we can use row 2 to eliminate. Now we can perform our action now. So we can pivot upwards from this row. Therefore, we can use row 2 to eliminate the y variable in the first row. So let's start off first. 0 1. So we have to add minus 3 times of row 2 to row 1 to eliminate the y variable. So minus 3 times 1 will give me minus 3. Minus 3 plus 3 will give me 0. Minus 3 plus times 0 will give me 0. 0 plus 1 will give me 1. So this is our reduced echelon form. Why? Every leading variable, every row has a leading variable of 1. And for that column which has the leading variable of 1, you can see here there is 1 is the only non-zero integer. So let's go on with example B. So we get 1, 2, minus 1, 3, 0, minus 3, 1, 4, minus 3. So now you notice that the second row has a higher coefficient of x than the third row. So we swap row 2 with row 3. Is row 1. Is row 2. This is row 3. Oh, hence swapping row 2 with row 3 will give me first 1, 3, 1. So minus 1, minus 3, minus 3, 2, 0, and 4. So now, this is our first row. Our second row and third row are swapped. So now, we can eliminate the x variables in the second and third row. So to eliminate the x variable in the second row, we add row 1 to row 2. So 1 minus 1 will give me 0. 3 minus 3 will give me 0. 1 minus 3 will give me minus 2. So for this, to eliminate the x variable in the third row, we have to add minus 2 times of row 1, add to row 2. Hence, minus 2 times 1 will give me minus 2. Minus 2 plus 2 will give me 0. And for this also, minus 2 times 3 is minus 6. Minus 6 plus 0 will give me minus 6. And for this also, minus 2 times 1 will give me minus 2. Minus 2 plus 4 will give me 2. So now we can swap it to make it into an echelon form. Therefore, you get 1, 3, 1, 0, minus 6, 2, 0, 0, minus 2. And now we can make each leading entry into 1. Since it's already in the echelon form, therefore again 1, 3, 1, and the second row you can divide by minus 6. So it's 0, 1, 2 divided by minus 6 is minus 1 over 3. And for the third row, you have to divide by minus 2, so that equals to 1. So now you notice here, it's already in echelon form because of 1. And now we want to use this last row to eliminate the y variables here in the first and second row. Hence, we add minus 1 over 3. We add 1 over 3 times of row 3 to row 2, and we add minus 1 times of row 3 to row 1. So let's work it out first. So 0, 0, 1. So minus 1, add 1 over 3 times of row 3 to row 2. So it will give me 0. 1 over 3 times 0 equals to 0. 0 plus 1 equals to 1. 0 plus 0 equals to give me 0. So now for eliminate the y variable, z variable on the first row. So minus 1 times of row 3 to row 1, which means minus 1 plus 1 will give me 0. Minus 1 times 0 will give me 0. 0 plus 3 equals to 3. Minus 0 plus 1 will give me 1. So now again here, and hence now we can use row 2 to eliminate the y variable in the first row. So we add minus 3 times of row 2 to row 1. So starting with row 2, so minus 3 times 0 equals 0, 0 plus 0 equals to 0. So minus 3 times 1 is minus 3. Minus 3 plus 3 equals to 0. And minus 3 times 0 equals to 0. 0 plus 1 equals to 1. So this is our reduced echelon form for part B. Now let's go on with the last example. This is unique because it has more columns than rows. So this is our matrix. 1 0 5 3 5 1 2 6 5. So what do? We notice that row 3 has the coefficient of x while row 1 and 2 doesn't, so we swap them over. So we first will swap row 2 with row 3. So again, step 1 5 minus 5 0 0 5 6. And now we can swap row 1 with row 2 again. Since row 1 has a lower coefficient, it's no coefficient of x while row 2 has, so it's 1 5 1 5 0 1 3 2 0 0 5 6. So the system is sort of in an echelon form. However, we will want to make the leading entries into 1. Therefore, we divide the third row by 1. Therefore, is 0 0 1 6 over 5. So now we can make it to reduced echelon form because it's already in echelon form with a leading entry of 1. So let's use row 3. Now we pivot upwards, so we use row 3 to eliminate the variables here. We are going to eliminate the z, x, y, z, the fourth variable here. Therefore is minus, so you have to make this to 2, so it's minus 5 over 3 times of row 3 add to row 2. Let's do this. So it's 0 again, 0 0 1 6 over 5. So minus 5 over 3 times 6 over 5 will give me minus 2. Minus 2 plus 2 will give me 0. The same goes for this. So it's minus 5 over 3 plus 3 will give me 4 over 3 minus 5 over 3 times 0 equals to 0. 0 plus 1 equals to 1. Minus 5 over 3 times 0 equals to 0. 0 plus 0 equals to 0. And now for this, you want to eliminate also the z variable, the third and fourth variable in the first row. So we times, we have to make this to a 5. So it's minus 25 times 6 of row 3 add to row 1. Therefore, minus 25 over 6 times 6 over 5 will give me minus 5. Minus 5 plus 5 equals to 0. And for this also, so minus 25 over 6 times 1 equals to minus 25 over 6. So minus 25 over 6 plus 1 will give me minus 19 over 6. So now for this also, minus 25 over 6 times 0 equals to 0. 0 plus 5 equals to 5. Minus 25 over 6 times 0 equals to 0. 0 plus 1 equals to 1. So we have nearly gotten it. So now let's use row 2 to eliminate the y and z variable in the first row. So therefore 0, 0, 1, 6 over 5. So 0, so now you want to make this to 19 over 6 so that we can eliminate this. So is therefore is so to make this to 19 over 6 we must 4 over 3 times 19 over, so let's do our working first. 19 divided by 6 divided by 4 over 3 will give me 19 over 6 times 3 over 4 equals to 19 over 8. So in other words, we must multiply 19 over 8 of row 2 and add to row 1 to eliminate the z variable here. So first, 19 over 8 of row 2 of times 0 equals 0. 0 plus 0 will give me 0. And 19 over 8 times 4 over 3 will give me 19 over 6. 19 over 6 minus 19 over 6 will give me 0. And the same goes for this also. So 19 over 8 plus times 1 equals to 19 over 8. 19 over 8 plus 5 equals to 59 over 8. And this one will give me 1. Hence the system is now in an echelon form. Reduce echelon form here. So now we have already come to the end of this tutorial. If you have any questions, please let me know and I will get back to you. Thank you so much for watching this video.